do if we made contact with an extraterrestrial civilization? This episode, I'm speaking to Emma Johanna Puranen, a St Leonard's interdisciplinary doctoral scholar at the University of St Andrews who combines astronomy, data science and media studies in her research on exoplanets in science fiction. We spoke about the search for extraterrestrial life, what would happen if we did make contact, and whether science fiction has us properly prepared.
Hi, I'm Emma Johanna Puranen. I'm a PhD student at the University of St Andrews, and I study how exoplanets are portrayed in science fiction. So I'm at the St Andrews Center for Exoplanet Science, which is an interdisciplinary group of researchers sort of studying exoplanets from all angles. We're doing detection and characterization, but we're also talking about space law and space ethics and linguistics, and we also are involved in some SETI research as well, in terms of if we were to make contact with aliens, how would we understand their messages? How would it change life on Earth, etc.? And that segues into my connection to the hub as well.
That's all. I mean, what an intro! It's all incredibly interesting stuff, isn't it? Do you ever have a boring day?
No, not really, because that's the beauty of being interdisciplinary, is if you get a little bit sick of one of the subjects, you can go, okay, I'll put that on the back burner for a second, transition to something else.
Well, thanks very much for coming on the podcast and speaking to me today, Emma. I thought it'd be worth just starting off by talking a little bit about SETI, the search for extraterrestrial intelligence. Because I suppose when a lot of people hear that, there might be an element of skepticism, or just sort of linking it or connecting it to things like ufology and UFO and alien visits and stuff like that. But it's a bit more scientific than that, isn't it?
Yeah, definitely. There's a lot of people first leap to this sort of I would call it mythology surrounding UFOs, but SETI is quite different. SETI, first of all, is an astronomy endeavor. It takes place beyond the Earth's atmosphere. UFO detections, or people who claim to have seen UFOs, that's all happening within the Earth's atmosphere, which is a much better studied area. We know a lot more about the Earth's atmosphere than we do about everything beyond it. So I think it would be a pretty tall order for aliens to have been hiding in the Earth's atmosphere and we didn't know about it this whole time. There are a number of astronomers who have written some really good think pieces on this that I would direct you to. Jason Wright at Penn State and Katie Mack at the Perimeter Institute in Canada. They've both written some excellent write-ups on why SETI and UFO lore are different things. But I think part of it too is that people who sort of believe in UFOs, they do talk in those terms of belief, don't they? Like X-Files, I want to believe style. Whereas SETI researchers are very skeptical. It would take a lot of evidence to convince most SETI researchers you talk to that something that they had detected really was a signal from aliens. SETI does have its origins in astronomy as well. The first SETI search was the first modern SETI search was by Frank Drake with Project Ozma, where he was at the Green Bank Telescope in West Virginia and was looking in the direction of the stars Tau Ceti and Epsilon Eridani, which are two fairly nearby, fairly sun-like stars. He was observing at the 21 centimeter hydrogen spectral line, which is that's a very, it's a naturally occurring radio signal in space. It corresponds to the energy of a photon emitted from a hydrogen atom during a spin flip transition. So it was thought that any intelligent species out there would be aware of this line and might use that frequency as sort of a cosmic hailing frequency. So that was a very science-based astronomy experiment to listen in the directions of those two stars. That project didn't turn up anything, but that's just SETI has some strong groundings in science as opposed to UFO lore.
You've touched a bit on it there, but what sort of technology and also techniques are open to SETI searchers?
Yeah, how do people actually do SETI? Well, first, I want to say that sort of the idea that there might be other life out there in the universe is actually very old. It sort of goes back to the Greeks, actually, but then it was suppressed by the church for about 1,000 years. until you get to the Renaissance, and you've got people like Giordano Bruno who said, and this is a quote from him, that there would be innumerable celestial bodies, stars, globes, suns, and earths that may be sensibly perceived therein by us. And if you start thinking about cosmic pluralism, the idea that every star out there is like the sun, you start realizing, okay, it makes sense that it would have planets around it. And might they have life? Might there be aliens or somebody else out there? And then how would you reach them? How would you detect them? How would you learn about them? So that's sort of the starting place for doing SETI science. A lot of SETI science, like this Project Ozma, is listening for radio signals, because space is really, really big. And unfortunately, we don't know of anything that goes faster than the speed of light, or perhaps fortunately, if you don't want aliens reaching us. But it just makes sense that civilizations would be sending signals with electromagnetic radiation, light moving at that speed of light, way before they would reach any sort of hypothetical ability to travel between the stars at a reasonable speed. On top of which, people tend to look in the radio part of the spectrum specifically, because those have much longer wavelengths and they're much less likely to get absorbed by anything in space. They penetrate the Earth's atmosphere very well, whereas the smaller wavelength light would be more likely to get absorbed. So those would seem like good places to send signals. So you've got a number of different groups active in SETI research today. You've got this project called Breakthrough Listen, which was founded by Yuri Milner and Stephen Hawking. You've got, there's a lot of activity in California. There's the Berkeley SETI Research Center. There's the SETI Institute, which is a not-for-profit and collaborates with the Berkeley SETI Research Center. They've built the Allen Telescope Array out there in California, which is the first telescope array that is dedicated to listening for SETI signals, but they also get a lot of time on other telescope arrays as well. Other things that people are looking for besides just listening to radio signals would include technosignatures. I love that word. Which would be stuff like signs of an intelligent species out there. So that would be, are you familiar with a Dyson sphere?
I'm not, no, personally, no.
So a Dyson sphere is a hypothetical structure. If you had a civilization that was advanced enough, they could build a structure that sort of goes around a star and captures all the energy coming out of that star. It's like unthinkably advanced for us. We have not even captured all the energy of our own planet yet. But if a Dyson sphere did exist, it would probably have some waste heat. You could detect that. That would be a technosignature. You could possibly detect effects of an intelligent species mining in their asteroid belt in their solar system, or there are technosignatures that like humans give off. Like if you look at Earth at night, if you've ever seen one of those pictures of looking down at the Earth at the night, you can see all the lights from the cities. People are looking into, would it be possible to detect night lights from cities on alien planets as well? So those would be non-radio signal ways of looking for intelligent life out there.
That's so cool. I mean, there's just so much to discuss there. You know, it's just one of those. It's definitely one of those, let's have a chat about it in the pub topics, I find. But
Absolutely.
it's definitely worth talking about the hub that you're involved in. And I think that the key in the title of the hub you're involved in is post detection. It's because that's really what it's all about, isn't it?
Absolutely, yeah. So a lot of the energy toward and excitement towards SETI has been in experiments to achieve detection, but what about after that? So that's where the SETI Post-Detection Hub comes in. So this is, we're based at the University of St. Andrews. It's run by Dr. John Elliott and Dr. Martin Dominic, and it's meant to be a coordinating center for an international effort to bring together expertise across the sciences and the humanities, to set out impact assessments and protocols and procedures for a responsible response if there was detection of an intelligent alien civilization. So this is sort of filling in a policy gap of what happens after contact, because there is really precious little written down about what to do in that scenario. The SETI Institute did write out some protocols, but they are for detection, not really for post detection. So it's one of those things that, like, you don't want to be stuck. You don't want to not think about it before it happens, right? You don't want to be uh like caught with your pants down when the aliens, if the aliens do ever show up. So it's one of those things you really have to think about ahead of time, and that is what we are aiming to do at the post detection hub.
Yeah. So is there much sort of protocol if you look at sort of bodies like NASA or the UN or like the Space Treaty and things like that? Is there much actual legislation and or protocol that actually exists at the moment?
No, not currently. And there largely isn't that much. You mentioned the space treaty. There is an outer space treaty that dates back to the 60s, that's at the UN. That pretty much governs human activity in space. It doesn't really say anything about aliens and SETI research. That's more was more politically motivated, as it looked like people were going to be moving onto the moon in the 60s and things like that. So this really is a policy gap that we're trying to think through scenarios of what might happen and have something prepared.
Yeah, I mean, it's one of those situations. Like I was talking to a friend about it one time who isn't really at all interested in sort of space or astronomy or anything like that. And he asked me, "Do you think that there's like life beyond Earth? Not even intelligent life, just life beyond Earth?" And I said, "Well, yeah, like they're more than surely there more than likely is." And he sort of looked at me as if I was like crazy. But I and you would know this a lot more than me, obviously. But don't you find that the more you sort of know about exoplanets and the universe and space and astronomy, you come to the conclusion that of course there's life beyond Earth. How could there not be? But for someone who doesn't really think about that sort of thing, it does seem like a crazy notion, doesn't it?
Yeah, well, yeah, I'd say there's two things there. One is that the vast majority of people don't think beyond Earth's atmosphere very much because it doesn't affect their day to day. If you're not an astronomer, there's, you look up, you see the moon, you see the stars, but you don't really interact with them on your day to day basis. So thinking about aliens is just not something that crosses your mind very much. But yeah, I haven't done a formal poll or anything, but I would hazard a guess that most astronomers I interact with think that it's far more likely there is life out there than there isn't, just because it feels like it would be very, I don't know, cosmically strange if we're the only planet that has life on it, given all we've discovered.
Yeah, absolutely. Yeah, so sort of perhaps existentially speaking, or philosophically speaking, what do you think it would mean if we did discover that there was indeed intelligent life beyond Earth?
Yeah, well, I think it would change life on Earth and the human experience sort of forever. Even a microbial discovery would in our own solar system, like let alone intelligent life. There's that quote from Arthur C. Clarke that goes, "Two possibilities exist. Either we are alone in the universe or we are not, and both of these are equally terrifying." Um, I would agree with that. I like to think we're not alone. I think it would be more terrifying if, personally, that's a me personally thing. I think it would be more terrifying if we were alone. But I think uh, science broadly and astronomy specifically have sort of been this continuous exercise of learning that we're not special. It goes back to the Copernican principle that we don't occupy a place of cosmic importance. So I think this would be a continuation of that. Learning that, and it would, like, you hear about astronauts who have been up to the space station talking about how their perspective on our planet is completely changed. I think it would be a moment like that, but for all of humanity. It would get a lot more people thinking about the non-Earth parts of the universe than currently do.
Absolutely. I mean, yeah, you're talking about Copernicus. How, for example, like the Church of the day reacted to the heliocentric model. Well, imagine how they would react to actual scientific proof that like life exists beyond Earth.
Hmm.
um, so, does does the does the post detection hub have sort of uh, theories or ideas as to what sort of protocols you would like from bodies like NASA and UN and the UN in terms of SETI?
Yeah, well, so not to be trite, but first off, we would like there to be protocols. um, I think I think it would be great for them to have a catalog of expertise at the ready of people who are studying things like linguists who are really good at interpreting, at deciphering encrypted messages, for example. Um, and then various plans in place for various scenarios that might come about. For example, we receive a message. Can we decipher it or not? What do we do in each scenario? What if aliens were physically present? What if what if we detect aliens, but neither species has the technology to travel, so therefore it's just going to be a back and forth over the radio waves scenario, like sort of gaming out a whole bunch of different possibilities that we think might arise. But we think it's very important to do this and do it on an international level so that if this were ever to come about, humanity could react in a way that is cohesive, based on evidence. It's international. No one's hoarding the signal, for example. And then also staying open minded about it, because we are in this sort of, I think, bizarre scenario. I study science fiction, and it's sort of science fiction's fault, where we actually have stereotypes about aliens, right? Like everyone thinks, oh, little green men, which is, we haven't detected aliens. How can we possibly have stereotypes about something that doesn't exist? And then if we ever did encounter real aliens, they probably wouldn't be anything like our stereotypes. So keeping an open mind and remembering that, I think, is very important.
Yeah, and you touched on something else I wanted to sort of speak to you about, and it's just this your interest in exoplanets, and well, your research into exoplanets, but your interest in like fictional exoplanets. And I was wondering, do you think that like really, I suppose the field of exoplanet science is really only, was it like 30 years old? It's really sort of like the 90s, isn't it? That, we sort of make the
Mm-hmm.
first confirmed discoveries of a planet existing beyond the solar system. Um, do you think that like those subsequent 30 years have 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 sort of changed our views on the search for extraterrestrial intelligence, and the possibilities, and the likelihood?
Yeah, absolutely. So, just for a brief overview, the field of exoplanet science is about 30 years old. The first exoplanets were discovered in the early to mid 1990s. And since then, we've detected 5,000 exoplanets. We hit the number 5,000 just this year, and everyone's very excited about this. It took a while to detect them because they are so dim compared to their stars. So, a lot of the detection methods that we use are these indirect detection methods based on observations of the stars themselves. But once we've started discovering them, it's sort of like the floodgates have opened, and now we found evidence that more stars in the galaxy have a planet than don't. There's if you just extrapolate the numbers we've been finding, there must be billions of planets just in our own galaxy, et cetera, et cetera. And before that, like it's almost wild for me to think, I'm fairly young, that there were people doing SETI research not even knowing for certain that other planets actually existed around other stars. I mean, again, it makes sense to assume that they are there, but not having the concrete evidence. And now we do. We have that concrete evidence. Exoplanet science has reinvigorated SETI efforts. A lot of SETI listening projects will target their listening on stars that we know have exoplanets, and especially ones that have exoplanets that would be in the habitable zone. That is the zone where liquid water could exist on the planet's surface. Um, it's also, exoplanet science has also given us new ways to search for life on other planets. It's not just listening for radio signals anymore, but increasingly we're hearing about searching for biosignatures, which are signs that life might be present on the planet. Now, biosignatures would be evidence in favor of life, but none of them are going to be definitive evidence of life the same way, for example, a clearly made by intelligent people message would be. So biosignatures would be evidence in favor, and these would be things like certain gases present in an atmosphere, and we are reaching the point of being able to detect gases in the atmospheres of these planets. So this is sort of a new era for SETI, the rise of exoplanet science and astrobiology.
What makes you come at exoplanet science from the point of view of sort of exoplanets or planets in science fiction, and how do you sort of approach that scientifically, if you know what I mean?
Yeah, so that's what my project is about. It's called Turning Science Fiction into Data Science. So I'm very interested in, well, science fiction as a genre and how it presents science, because although it is fiction, science fiction is always based on or inspired by an idea from real science. And because we have this interesting scenario with exoplanet science where real exoplanets were only discovered in the 90s, but we have decades and decades of science fiction works featuring exoplanets from before then. I'm able to sort of compare and see how that scientific knowledge has sort of been transported to science fiction readers through the medium of science fiction authors, like all this new data we're getting about exoplanets. So what I do for my research is I'm compiling a database of fictional exoplanets, and then I'm using Bayesian network analysis, data science, to determine how various characteristics of the fictional exoplanets influence various other characteristics. So I can see things like how publication date will affect the likelihood of there being life on the fictional exoplanet, for example.
Whoa, like what sort of thing would determine that?
Yeah, so I've found so far that the planets that are in works written after the discovery of real exoplanets, so the fictional exoplanets from post 1990s, they're getting weirder. They're actually getting it's getting less likely that there's native intelligent life on the planet. It's getting less likely that humans can survive on the fictional planet. So I think possibly I'm getting ahead of myself here a little bit, because I'm sure I'll talk about this later. But I think the weird discoveries from exoplanet science have been influencing authors, certainly, to feature stranger fictional worlds that are less human friendly.
So, if you look back at sort of science fiction planets before the 1990s and then after the 1990s, or even just considering what we now know about the exoplanets that we have confirmed and studied a bit, did science fiction writers get it right? Were they way off?
Largely, I'd say no. They didn't get stuff right about exoplanets. That's not they're not a monolith. There's definitely some that had some really creative ideas. But I always like to say science fiction is written by humans for humans, typically about humans. So you end up with a lot of very Earth-like worlds, which is not necessarily the same population of real exoplanets that exist. And a lot of that is just because you've got humans in the story and they need to be comfortable. So you've got a lot of very Earth-like fictional exoplanets from both before and after discovery of real exoplanets. But yeah, largely no. They got some stuff right, like the existence of planets that orbit two suns, for example, Tatooine. And it's to the point where when you see popular science reporting on exoplanet discoveries, if they find one that's orbiting two suns, they'll call it a Tatooine planet,
Yeah.
because that's a quick way of connecting with the audience. Everyone knows Star Wars, knows what that means. Hot Jupiters really threw everyone for a loop, like everyone. So the first discovery of an exoplanet around a sun-like star is what we very creatively have termed a hot Jupiter. That is a very massive gas giant planet that orbits very close to its sun. So nothing like that exists in our solar system. In our solar system, we've got all the small rocky planets close to the sun, and the big gas giants like Jupiter are much further away from the sun. And nobody expected there to be gas giants with such short years orbiting so close to their stars. That didn't make sense with the models of solar system formation that we believed to be the truth back in the 90s or before detection. I can't find hot Jupiters in science fiction. If anybody out there has found a hot Jupiter in science fiction even today, let me know because I'm curious. But that surprised astronomers and it surprised science fiction writers. I'd say that largely the mantra of truth being stranger than fiction is true.
What about sort of after, or well, in the present day? Have you found any that planets in science fiction are a bit closer to what we're actually seeing in exoplanet science?
I've definitely seen some examples. Yeah, it's like I said, the data is overall showing that they're getting less Earth-like overall. I've got some. I have some of my favorite examples of fictional exoplanets, though, come from both before and after discovery. I really love Becky Chambers' novella "To Be Taught If Fortunate," which features a team of explorers on 4 different exoplanets orbiting a red dwarf. It a little bit reminds me of the TRAPPIST-1 system, which is a system of 7 exoplanets all orbiting very close together around this tiny, dim little red dwarf star. That's, I think, one of the most I think scientifically accurate portrayals of an exoplanet mission I've ever seen. That's Becky Chambers, "To Be Taught If Fortunate." But then there's some strange creative stuff from, and that's a recent book, but there's some strange creative stuff from before exoplanet discovery as well. A lot of Larry Niven's planets in his books are very strange. There's one in his book Integral Trees, which it's actually a gas giant orbiting a pulsar, which is a dead remnant of a massive star, but it orbits so close to the pulsar that its atmosphere is stretched to the point where it's in a toroidal shape, like a donut shape. There's the core of the planet, and then there's this like endless donut-shaped atmosphere of the gas going around the star. I don't think that's physically possible, but it sure is creative, and there's a lot of people living in this sort of endless sky. So yeah, there is definitely some creativity out there as well.
So, how do you think that, if we come back to SETI, how do you think science fiction throughout the ages and even now has prepared us for the possibility of making contact with an alien civilization? Because, I mean, maybe it's just my own experience or the sort of media that I consume, but it tends to be that aliens are hostile in the things that I read and watch, but maybe that's not been the case. Do you think sci-fi has ill prepared us for eventual contact?
Yeah, well, yeah, definitely there's a lot of portrayals of hostile aliens in science fiction, like War of the Worlds and Alien. I think overall science fiction it's a powerful tool, but it's one that you have to be careful with. I sort of see it as like a repository of humanity's imagined futures. So I think it's very important to look at how we are imagining the different ways this might go. But you do have to be careful with like what I said earlier about having stereotypes about aliens, which doesn't make any sense when you think about it. I even catch myself sometimes thinking, "Oh yeah, I'm familiar with first contact scenarios," but of course that's not true. We haven't experienced a first contact scenario. Um, I think that a lot of that hostile aliens and science fiction thing sort of comes out of a fear of the unknown. Um, and to study subjects like astrobiology, exoplanet science, search for extraterrestrial intelligence, where so much of what we're doing is really facing the unknown, you have to get comfortable with the unknown. And I think science fiction can actually help with that. I think it does an excellent job of sort of letting us experience different points of view. It'll estrange our perspective, put you in the shoes of somebody else for the course of reading the book, and then you can come out of it with some new empathy, I think. So I think we have to be careful with it, but it can help us if we let it.
Yeah, I'd never thought about it like that before. That's awesome. Like it's sort of almost like a really good tool for sort of preparing us
Mm-hmm.
for what might come. Yeah, that's awesome. I'd never thought about it like that before. That's so cool. Do you look forward to the future as in terms of bigger and better telescopes, new technology to search for? I mean, even just things like the James Webb Space Telescope or the Square Kilometre Array Organization. Are you sort of looking forward to what these new observatories will show us?
Absolutely, yeah. So JWST launched last Christmas. We've already been getting some really excellent data from it. I've seen some of the results. It's all very exciting. The biggest area that I think JWST will be able to help SETI researchers in is in studying exoplanet atmospheres, and it can do this using this technique called transmission spectroscopy. So some exoplanets, from our perspective here on Earth, will be sort of fortuitously aligned such that we see them pass across the disk of their star as they orbit it. So every year it'll come around, we'll see it sort of eclipse the disk and it'll block a little bit of that light. And when that happens, some of the star's light is just getting completely blocked by the planet, but also some of the star's light is passing through that sliver of atmosphere on the edge of the planet's disk. And so, if you can catch a spectrum of the light, you can sort of see what wavelengths are being absorbed, and that will tell you what chemicals are making up the planet's atmosphere. You can get a spectrum of the star's light when there's no planet in front of it, and then a spectrum when the planet's in front of it, see the difference, and figure out what the planet's atmosphere is made of, which I just marvel at that because, again, these are planets that we can't actually see because they're so dim compared to their stars, and we can tell what's in their atmosphere. JWST just last August released some data from its one of its instruments called the near infrared spectrograph, which is the most useful for this atmosphere transmission spectroscopy. They've detected carbon dioxide in the atmosphere of this exoplanet called WASP 39. That's the first time we've detected carbon dioxide. It's very exciting. Now, this WASP 39 is one of these hot Jupiter planets I was talking about. It's very close to its star, which means that its atmosphere is highly irradiated. And because heat makes things expand, the atmosphere is very puffy. That's the technical term. That makes its atmosphere easier to detect, but we do think JWST will also have the capability to detect and measure carbon dioxide in thinner atmospheres, smaller rocky planets, which, if you're looking for habitability, is really, really where you're looking. So this would be very useful for SETI in terms of looking for biosignature gases, which I talked a bit about earlier. That would be evidence in favor of life. This would be things like oxygen, of course, as well as anything in the atmosphere that's out of thermodynamic equilibrium. For example, if you see methane with oxygen, those are two gases that can't really exist together without they'll just react and they'll form water and CO2. So they can't exist at the same time without being replenished by something. And on Earth, that's life that's doing that replenishing. So that would be an indicator that there's some sort of mechanism on that planet that is continuously replenishing this gas into the atmosphere. So that's sort of how biosignatures work. You would look into it and figure out, okay, how are all the abiotic, not caused by life, ways that this might be happening, and see if you can rule those out. And if you can, then there's a chance it might be caused by biology. So JWST is really giving us the most exquisite look at exoplanet atmospheres that we've ever had, and it's tremendously exciting to be seeing the data from that.
Absolutely. I mean, it just feels like, well, not even SETI, but even just the search for some sort of microbial life. As we sort of said at the start, it does just feel like an inevitability even within our lifetime, doesn't it?
Yeah, especially if we were to find microbial life elsewhere in the solar system, and we were able to determine that it didn't have the same origin as Earth life. Just the fact that life might have started twice in the same solar system, that would be an incredible discovery.
I know. I mean, like, what are the chances of that? And if that can happen in one solar system, then it just has to be happening in multiple solar systems, even within our own galaxy.
hmm Yeah.
Fantastic. Well, there's just so much there. I mean, I'm sure we could talk about this all day. But yeah, I want to say thanks for coming on the podcast, Emma, and for speaking to me today. And good luck with your research and your study of science fiction exoplanets. It's so cool, really, really interesting. And good luck with the post detection hub. I'll be really interested to hear more about that as the maybe next year, and we'll see what happens.
Yeah, thank you very much for having me. I'm super excited to dig into more SETI research with the Post Detection Hub. And if anybody out there listening has found a hot Jupiter in science fiction, you know how to contact me.
Cheers, Emma.
Thank you.